Okay, we need to talk about how an oscilloscope works. We're going to be using well, we would have been using oscilloscopes, but you still need to know how to use it, how to make it work, and how to read the patterns that would be on an oscilloscope to be able to do some problems when you need to figure out an unknown frequency. So this is an oscilloscope here, and let's see, I'm going to change some green, I think. And what we have here is in the front we have this this fluorescent screen right here. That if an electron hits the back of the screen, it'll actually kind of glow green. So I have a whole bunch of these old school oscilloscopes in my classroom, and I'd like to have shown you them, but we're just going to have to kind of do an online version of this, I guess. So what happens is there's electrons that come through. Shooting through here, and there's two sets of metal plates. This first set are their vertical plates, even though they're called horizontal deflection plates. Horizontal deflection plates. I'm going to change this to a brighter color. I'm going to use red. Horizontal deflection plates, and even though they're vertical plates. So what happens is these metal plates, I can actually put a charge onto them. So like I could put a kind of a more of a plus charge on this front and maybe a negative charge kind of on the back. And so what would happen to the electron if the electron coming through here on this path comes straight and there's no charges on any of the plates, the electron will hit right here in the middle and make a kind of a dot on the screen. Okay, but what happens if one of these charges these plates are charged like they are right here? Well, electrons are negative, and opposites will attract. So when this electron starts coming through here, it'll actually get it pulled over towards this plate here that's in the front. So it would actually kind of move over this way. Now, if I change the charge and I made this front one negative and the back one positive, okay, like this, okay. Then all of a sudden now the electron as it's going through would get attracted over to that back plate. So the electron would actually move clear across and it'd be over here somewhere. You'd see a dot on the screen over there. So the way that this works is there is actually plugged into the oscilloscope. I'll plug it into these cords right here, but there is actually a machine that I would have. It's called a signal generator. It's a really simple machine. It has a big dial on it, and you can just dial in whatever frequency you want. So I could dial in like 60 hertz, something like that. Now what that does is that this is an electrical signal, but we can still call it like waves. So it'll actually make the charges on these plates, it'll make them switch back and forth, whatever this frequency is. So it'll make these charges switch back and forth like 60 times in a second. 60 times in a second. So what happens when the electron goes through these plates? Well, the electron will just go back and forth, back and forth, back and forth. Actually go back and forth 60 times in 1 second. That is faster than your eye can actually see the dot. So it'll actually make it look like a line if this was the only thing I had hooked up. Now, what happens, though, is the electron then goes through vertical deflection plates. These are horizontal plates, but they're vertical deflection plates because the same thing can happen here. I can have a signal generator here and put it on something like 60 hertz also, and that'll oscillate the charge on these plates back and forth also, 60 times per second. So this will make an electron go up and down, up and down, up and down. So these vertical deflection plates basically are controlling what we call the vertical or the Y value, and the horizontal is controlling the X value of the electron. And that's all you need to be able to draw basically anything on this top screen. So depending on the frequencies that I have on these two devices here, we can get different patterns. And it's going to be your job to be able to interpret a pattern to know what a frequency might be. For instance, if we have a complete match, 60 hertz and 60 hertz, what will end up happening is the electron will actually go around in a circle, and we'll get a circle Lissajou pattern on there. Now it won't stay as a circle. These frequencies, these two waves right here are kind of going in and out of phase. And so this Lissajou pattern is what we call it. These patterns are called Lissajou patterns, Lissajou. They will oscillate through kind of rotate around. So if they're actually in phase, these two waves, 60 hertz waves, are in phase, it'll actually look like a diagonal line like this. If they're 90 degrees out of phase, you'll get a circle. If they're 180 degrees out of phase, you'll get a diagonal line going up the other way. And if they're 270 out of phase, you actually get a circle again. Okay? But what we're looking for would be like a circle to see on this screen right here. It'd be a circle, and we would know then that the patterns are the same. Now, the way we use this as a tool in physics is we technically don't ever have another signal generator hooked up. It's kind of dumb to have two signal generators hooked up. We want to use an oscilloscope to actually determine an unknown signal. So what I might have hooked up to this thing would be like a microphone. Okay, we'd have some kind of a microphone hooked up here, and we'd be speaking into the microphone, or we'd be singing into the microphone, la, some kind of a note, and then we can come here and start playing with this dial until we see a circle on the screen. If we get a circle on the screen while I'm singing a note in this input signal here, then and I find out that this signal thing is like 30 hertz when I finally get the circle Lissajou pattern, then I know that the signal that I'm singing is a 30 hertz signal, which would be a really low note. So probably about impossible to do that. But anyway, that's what we're going to do. We're going to have an input signal, and we're going to use an oscilloscope to be able to determine what that input frequency is of something. Okay. So maybe that helps you with the internal structure of how this whole thing works. We can get a whole bunch of different other patterns, but I just wanted you to know that one of these plates control the X and the Y controls. This is, remember, like an Etch-a-Sketch. Remember, there's two knobs on it, right? And one actually controls the back and forth, and one controls the up and down. One is an X, and one is a Y knob. And unless if you're ELF, right? If you're the ELF, you can make any kind of pictures you want on here if you know how to just control the X and the Y kind of individually, right? So that's what's happening here, and we can get different spirograph Lissajou patterns on the oscilloscope, and what we need to do right now is learn how to interpret them. Okay, so what we're going to do, I'm going to move that out of the way, I hope. Let's see. Oh, maybe can I shrink it down? No, I can't. I'll just take that on top. There we go. Okay, sorry about that. So what we're going to do is we're going to go to this online oscilloscope here that we have. And we're going to put in some frequencies here. Okay, so you probably hear that sound. There's a frequency sound there. I'm going to turn the volume down so we don't hear that. Okay, so let's say I put in like 300 hertz here. Okay, I hit return, and here I'm going to put in 300 also. Okay, if I do that perfectly, then you kind of see kind of a circle. But I don't actually want to make these perfect here because I want to show you what an oscilloscope really looks like when it's kind of rotating around. So there we go. If I put in, kind of make it just be a little bit off, it'll rotate, and you'll see that it'll rotate into a line going up and down like this. See, that's 0 degrees, and then it gets to a circle. It's 90. So that's 0. That's 90, and there's 180, and now there's 270, and now it's back to 0, and now it's 90, and then it's 180, and so it's kind of an oscillating kind of a thing there. Okay, and so we have. This is a 1-to-1 ratio on our two signals. All right, so here's where it gets interesting. We're gonna take this one. We're gonna take this one here, and we're gonna make it 600. And look at what we got. We have this new kind of spirograph Lissajou kind of a pattern here. And what I want to do here is I'm going to try to freeze this and kind of do a little drawing for you here to be able to interpret these Lissajou patterns here. If I can do that. That's not great. I'm going to let it go again. Let's see here. Boom. Nope, still not good. Let's see if I can freeze it. Okay, that's a lot better. Okay, so what I wanted to do here is you get a Lissajou pattern, and you need to kind of let it rotate into its open form like it is right here. That's what I was trying to do there. Okay, now what you're going to do to figure out this pattern is you're going to draw a box around it. So you're going to draw a box around the Lissajou pattern. Okay, and you're going to get a lot of the questions like these on the test, so you need to know how to read a Lissajou pattern. And what you're going to look at is you're going to look along the top of the box, and you're going to look down the side of the box. And you're looking for points of tangency, which that basically means where does the Lissajou pattern touch the side of the box. So up here on the top, there's only one place where the Lissajou pattern touches it, and it's right here in the middle. Okay? Now if you look at the side of the box, there's two places that it touches over here, right there, and right there. Okay. Now when you do that, you'll notice that I have a vertical line here, and over here on the side I have two horizontal lines. So the vertical line is my Y. And how many vertical lines do I have? I have one. Okay? And my horizontal lines are X, and those I have two of those. Okay? You can use Y and X, or you can use vertical and horizontal. I don't really care how you do it. Okay? But any Lissajou pattern shows you a ratio of the frequencies that are over here. Okay? A Lissajou pattern shows you the ratio of the frequencies that are over here. Now look at these frequencies. I have 600 and 300, right? F1 is twice what F2 is. So which frequency is F1? Is it the vertical or is it the horizontal? And see, your pattern here says that the horizontal is twice your vertical. So this right here, this F1, and you're going to have to remember this because I'm going to delete this drawing here in a second. Your F1 on this oscilloscope is your horizontal signal, and your F2 is your vertical signal. Okay? Vertical signal. So the way this works is I'm going to give you on a test, I'm going to give you, like, I'll say the horizontal signal is 600 hertz. The vertical signal is unknown. Let's pretend you don't know it. I mean, cross it out there. You don't know what it is. And here is the Lissajou pattern that you get. So you need to tell me on the test what is the vertical signal. So what you do is you put the box around it. You say, okay, one vertical and two horizontal. So you do like vertical over horizontal. For my Lissajou pattern, that's 1 over 2. And then from your frequency, you were given a 600 horizontal. What is the vertical? And all you do then is cross multiply and divide. 600 times 1 divided by 2. Your vertical would be 300, and that's how you would solve the problem. Okay? All right. We need to test that a little bit here more. So let's do a different pattern. By the way, what I can do is I can make this a 300, and then I can make this a 600, and now you'll see it's this way, right? It's this way. And of course, if I freeze it and I draw my box around it, right? Now what do I have? I have one horizontal and two vertical. See? Two vertical. So now the vertical is twice the horizontal signal, and you can still use it to figure out Lissajou patterns. Okay. Let's do something a little more tricky. Let's do 300 and 200. Okay, we get something like this. And if I get lucky here, and it's not, I'm going to go with that. That's not too bad. It didn't quite open it up the way I wanted to, but it's not bad. It'll still probably work. I have 1 point there and 1 point there vertical. And horizontal, I have 1, and I have 2, and I have 3. If I had it nice, really nice and open, they would kind of, it would have been better. But it doesn't matter. Vertical over horizontal is 2 over 3 from my pattern, and that is the 200 over the 300, right? And see, I would have been able to figure out one of these things if I didn't know either of them, okay? So you got to get a Lissajou pattern. A Lissajou pattern tells you the vertical to horizontal ratio, and you just need to use it to be able to figure things out, okay? Let's say, what if I had 300 to 100? What would that look like? Okay, there it is, and you can see if you could freeze it when it's like, totally open. Maybe I'll just make it, let's see, it's not going to work. That's not the open part here. Maybe I can make it go slower though, or not. Okay, so then boom, right there, it's kind of, there's one vertical, right? And there would be 3 horizontals, right? 3 horizontals, so it's 3 to 1 ratio, and that's how you figure out your signals again. Okay, let's do 500 and like 400. Okay, and I'll see how good if I can freeze this in the nice open spot. Wasn't very good. Let's try it again. Nope. It's really hard to do this just perfectly. If I could pause it on there, I can't pause it on there. You gotta get lucky. Ooh, hey, there's a good one. Got lucky. Okay, so I draw the box around. I got 1, 2, 3, 4 places where it would touch the top. I got 1, 2, 3, 4, 5. So I could do horizontal over. It doesn't really matter what the ratio is. Just make sure it's right. Horizontal, I have 5 of those, and I have 4 verticals. And so the vertical signal here was 500, and the horizontal here one was 400. So the ratios work out, and that's how you can interpret Lissajou patterns. So hopefully you can hopefully understood that, and you can make that work on your test.